All right, so we're in section 3.3, excuse me, percentiles, quartiles, and box and whisker plots. Percentiles, deciles, and quartiles are based on relative position, just like the median is of data. So unlike the mean, which utilizes every data value, they're not affected by extreme values. Percentiles divide the data into 100 equal sections. So by definition, the pth percentile, where 1 is less than p is less than 99, is a value such that p% of the data fall at or below it. Notice the at or below it part. And 100 minus p% of the data fall above it. So for example, say you score in the 90th percentile on some standardized test, then 99, or excuse me, then 90% of the others taking the test scored at or below you. And take a look at guided exercise 6 and figure 3-7 on page 113. Let me do this. And let's take a look at this. All right. So here's figure 3-7, by the way, on page 113. So notice you're going from the lowest to the first percentile, second percentile, third percentile, all the way up to the 99th percentile, and then the highest, which is the 1% at the very top, right? So that's figure 3-7. And make sure you take a look at guided exercise 6. When you're calculating percentiles, what you do is arrange the data in ascending or increasing order. Then you calculate this index I, which equals P, divided by 100. Notice that's in parentheses, times N, where P is the percentile you want and N is the number of data items or observations. If that I that you get, if you calculate I and it's an integer, the pth percentile is the average of the data items in positions I and I plus 1. In other words, you add those two data items together, divide by 2. If I is not an integer, you round up to the next integer to get the position of the pth percentile. So here's a bit of an example for you. Find the 30th percentile for the following. And so this is just something I made up. It's not in your book. But it's 1, 2, 2, 2, 3, 4, 4, 5, 5. Notice it's going from decreasing to increasing, right? Lowest to highest numbers. So according to our formula, let's move it right back so we can see it. For item number 2 up here in calculating, or step number 2 in calculating percentiles, we find I, which is P divided by 100th. Well, 100, we're finding the 30th percentile, so it's 30 divided by 100 in parentheses times 9 because there's 9 data items. That turns out to be 2.7. So this is where I is not an integer. We round up to the next value. So we round up to 3. The 30th percentile, excuse me, is in position 3. And if you take a look at the data, position 3 is this 2 right here. So it's 2. Deciles divide the data into 10 equal sections. The first decile, by the way, is the 10th percentile, and so on. You can calculate using the percentiles method as shown above. It's just remember that you're doing deciles instead of percentiles here. Quartiles divide the data into 4 equal sections. So the first quartile is the 25th percentile, and so on. This is the quartiles are what we're going to be using when we're doing what are called box and whisker plots. And let me pause this. Oops. Wrong button. Pause. All right, so the quartiles divide the data into 4 equal sections. The first quartile is the 25th percentile and so on. We're going to take a look at a figure here, and here's some other things that you should look at as far as examples and page numbers that you can see them on, as well as guided exercises, okay? So quartiles, here's figure 3-8, which is recommended to look at. Notice here's your lowest value. This is arranged in order, least to greatest, just like percentiles are. Here's your first quartile. That's the first 25th percentile. Your second 25th percentile, or the 50th percentile, is referred to as the median. Your 75th percentile is the third quartile, Q3, and then there's your highest value. And what you're going to see is this 5-number summary, as it's referred to, is what we use to make box and whisker plots. One of the things you'll need to be able to do is find the interquartile range, or IQR. That's going to be Q3 minus Q1. That's actually going to make up the edges of the box of your box and whisker plot. Box and whisker plots are used in what's called exploratory data analysis. They utilize what's called a 5-number summary. You have your lowest data value, then you have your first quartile Q1, your second quartile Q2, third quartile Q3, and your highest value. If you have an odd number of values, the median is included in both the upper and lower halves. So make sure you take a look at the procedure, how to make a box and whisker plot, page 116. See example 11 and the box and whisker plot, and then see guided exercise 8 on page 117. And remember, when you're looking through this stuff, when you have a guided exercise like the one that I recommended that you take a look at, you can click on these and it'll show you the answer for the particular questions that are being asked. If you're not graphing outliers, let me maximize this. If you're not graphing outliers, here's how you make a box and whisker plot. You draw a box using Q1 and Q3. The box contains the middle 50% of the data. Then you draw a line inside the box for the median, and then you draw lines going from the box to the largest and smallest data values. Bear with me while I pause again. All right, so this is the procedure on page 116 about how to make a box and whisker plot. Now notice this says for step 1, you're drawing a vertical scale. That's what this example shows. It can also be a horizontal scale. When I show you how to do this on a graphing calculator, it's a horizontal scale instead of a vertical scale. So you draw a vertical scale to include the lowest and highest data values. And then you draw, to the right of the scale, you draw a box from Q1 to Q3. Then you include a solid line through the box at the median level. Then draw the vertical lines called whiskers that go from Q1 to the lowest value and Q3 to the highest value. Let me bring up what they're talking about here. So again, this is vertically oriented, but it's not always vertically oriented. Again, on your graphing calculator, it's going to be horizontal. But you have your scale over here, and then here's your lowest value right here. That's at the edge of the whisker. And then it goes up it keeps popping this up. It goes up to Q1, your first quartile, and then for the data value, if the median is here at this point, that's where the median is. Notice the top of the box is Q3, and then from Q3 up to the highest value, you draw the other whisker at the top of the box. And so here's the steps that we just talked about here. And actually, let me pause it again here to bring something else up. All right, so what I've done is I've popped up my TI-84 Plus calculator for us to take a look at. Now, again, if you look through the examples and procedures and things of that nature and the guided exercise, they talk about, well, they show there are tech notes in this section, as there are in all sections, on how to do this stuff on a graphing calculator, which I would recommend. So down here, I just made up some numbers here that aren't in your notes that are actually going to be printed or looked at by you. In fact, I'm having to go through and upload or redo everything because of the way that they've rearranged the textbook. So I think I talked about that early on, but I'm not sure. At any rate, let's take a look at these numbers here. The set of data 1, 1, 2, 2, 2, 3, 5, 6, 6, 7. And let's use that to make a box and whisker plot. So what I'm going to do is I'm going to press the stat key. We're already in edit, option number 1, edit. So I'm just going to press enter. And what I'm going to do is enter this data in list 1. So here's 1, and then press enter after every entry. There's 1, 1, 3, 2. So 2, 2, 2, 1, 3, a 5, 2 6s, a 6, a 6, and a 7. And then I'm going to press enter. All right, so we've entered all of our data. Above the mode key, you'll see the word quit. I'm going to press second mode and access quit, and it backs me out of that. What we want to do is make a graph of that data. And above the Y equals key, you'll see the stat plot. That's what we want, is we want to plot this histogram. Or not histogram, box and whisker plot, excuse me. So I'm going to press second. I'm going to press Y equals. Notice the plot is off. We'll do this in plot 1. So we got to turn it on. I'm going to press enter. And it's flashing on. I'm going to press enter. All right, it's now on. Now we have to figure out what type of plot we want. So I just press the down arrow and look at where I am. That's a dot plot. And what, you can see other types of plots. Here's a histogram. Here's a box and whisker plot with outliers, which we're not going to cover. This is the box and whisker plot we want right here. So I'm going to press enter and then watch what happens where it says X list and Y list here. It goes down to the X list and at frequency 1. So this is the type of graph that we're going to get here, right? So I'm going to do second and quit, which is above mode, and then I'm going to graph it. All right, so here you see a graph of that particular data, right? And again, this is like what you see in the notes down here. It's horizontal instead of vertical, like what it talked about in the textbook. So what we want to do is, well, first of all, actually, let me go in and do this. I'm going to press this key called trace. And it takes me to the median, which is 2.5 of that data. I'm going to press the left arrow key. There's the first quartile. Q1 is 2. I'll press the left key, the left arrow again. Here's your minimum value, the lowest value. So there's your minimum Then your box starts after the whisker, right? Q1 is 2, your median is 2.5. Q3, your third quartile is 6. You notice I'm pressing the right arrow key going right. And then your maximum value is 7. So this is much easier to do on your graphing calculator than it is by hand, depending on the amount of data that they give you. So let me pause this. All right, box plots can be used in something when there's box plots that are made from different data groups and then they can be compared. That's referred to as comparative analysis. We're going to take a look at problem 13 on page 120. Let me pop that up. All right, so we have auto insurance interpret graphs. Consumer Reports rated automobile insurance companies and listed annual premiums for top-rated companies in several states. And then this figure 3-13 shows the box and whisker plots for annual premiums for urban customers, married couple with one 17-year-old son in 3 states. So this is actually drawn like it is on the TI-84, which is where they, copied the image here. Now I'm going to let you go through this and answer it on your own as part of your homework. But comparative analysis, you can actually put this stuff on the same, put these 3 different, in this case, box plots on the same graph and compare them. So for example, the highest premium would be here in Pennsylvania, right? It's going left to right as you're reading this. But make sure you look over that and make sure that, go through the recommended exercises and recommended things to look at, the pages to look at, and then, see if you can figure it out. If it takes too long or if you just want to look at the answer, click on the show answer, right? Pennsylvania has the highest. And then box plots are handy because they can also give information about the shape of the distribution of data. So here's some common patterns. If your median is here farther to the left and it's not in the center, it's going to be skewed right. If it's right in the center, it's symmetric. And then if it's off to the, I'm sorry, yeah. And then if it's off this way, it's skewed left. So take a look at that and take a look at these recommended homework problems. And if you see other problems as you're going through or examples that you want to work where it's before they get to the problem section, feel free to do that. Any additional homework problems out of the actual homework section area, feel free to do those and check them as well.